Have you found your dream job as a developer? Or are you stuck in an unfulfilling job? On WeAreDevelopers.com, you find over 1,000 jobs in Europe that fit the tech stack that you want to work with, and salaries go up to $130K. All you have to do is create a free profile, and you automatically get matched with jobs that fit your requirements. So what are you waiting for? Create your free profile and let companies apply to you now.
Hello, everyone. Welcome back. Welcome back. Now, for the next hour, we are going to be diving into peer-to-peer networks, how they work, and I was promised we're going to see the Lisk SDK in action as well. So exciting stuff, and maybe at the end, a workshop will be announced. So, a lot of good stuff. Now, I should say actually that Lisk, which is the next speaker works at, company that next speaker works out, is one of the sponsors of this, or partners of this event. And I'd like to briefly give a shout out to all of the amazing partners that made this event a possibility. Without them, we wouldn't be able to enjoy the amazing talks we have here today. So big thank you to the main partner, Crayon, but everybody else, all of the featured partners, all of the media partners as well. And last but not least, also the community partners and friends. A big thank you to all of you. Now, I get to announce our next speaker, and I'm really looking forward to this. His name is Ishan Tiwari, and he's going to take us with him in the world of peer-to-peer. Hello, Ishan.
Hey, hi, Justin. Yeah, thanks for the introduction.
My pleasure. Thank you so much for your presentation, and I'm really looking forward to it. So I'm going to get out of your way. Best of luck, and enjoy yourself.
Yeah, thanks a lot. I'm introduced by Justin. I'm Ishan Tiwari. I work as a backend developer at Lisk, and I have been working for Lisk for the last 2 years, even more. And I have a background in distributed systems and services, and I have worked in advertising tech in my past as a lead developer, and also I have worked as a senior software engineer at one of the healthcare domains. So today I'm going to talk about peer-to-peer networks, and also digging a bit into Lisk SDK. Just to give a short introduction to Lisk. So Lisk is an open source platform which enables developer to develop blockchain applications using JavaScript. Our motto is to make complicated technology like blockchain accessible to everyone. Given that JavaScript is widely used language, it's one of the popular languages in the world. And also we are simplifying our Lisk SDK as much as we can, so that users just focus on their use cases while building applications. Also giving some background of Lisk network. Lisk core is created using Lisk SDK, and it has been running from last 4 years in Lisk main network, and also Lisk test network. And we are using DPoS, which is delegate proof of stakes, and which is a bit similar to proof of stakes, but we have delegates which are chosen to create blocks based on the votes they get. So it's like a democratic system where anyone who is holding Lisk can vote for some validator, and that validator in the given round can create a block. So so this is the background about Lisk. So the theme of my talk is around P2P networks and blockchain, and I'm going to talk about peer-to-peer networks in general, their types, the communication protocol that is being used, then giving some introduction to Lisk P2P networks, and introducing Lisk P2P library, which is powering this Lisk peer-to-peer network. And in the end, I will introduce you to Lisk SDK, which is like a bigger, like the software developing kit, the main product from Lisk that is also holding this list library, list P2P library inside it, and some exciting developer features that we have introduced with the recent version 5.1. So yeah, starting with peer-to-peer networks, you might have heard a lot, maybe just giving like very very basic definition, you can say, or basic meaning behind it. So we have like two kinds of communication structures in internet today, and mostly it is centralized network. So where we have this client-server paradigm, and where like clients are the users who are requesting some data or like posting some data, and the servers are taking care of that data and handling it in their servers. So most of these servers are kind of centralized in a way that they are controlled and governed by a single organization. So they are in control of your data, users' data, and so users don't have that much of autonomy and control over their data. On the other hand, P2P network, we have nodes, and nodes like make up the whole network. And the nodes can act as client as well as server at the same time. So it's like a software that everyone runs in their laptop or their machine, and it will fulfill the request coming from the network, and also it can like request certain things. Maybe you have tried torrent. You are also uploading some files as at the same time you're also downloading a lot of things. So it's similar to that. In this case, the data is quite encrypted and it is distributed, so everyone has some sort of copy of all the data, and the users have more control over this data and have a bit more autonomy in this case. So in P2P network, there can be two types. So one is structured, one unstructured at a broad level. So structured network, they impose some sort of structure. For example, Kademlia enforces tree-like structure, and it depends like on the DHT they are using, where DHT stands for distributed hash tables, which is to look up peers or resources over the network. It's like a hash table. So so it imposes some sort of structure. So this kind of network is pretty efficient in finding a specific resource in the network. But at the same time, it has some drawbacks, like when you are scaling it into a very large network. It could be like if a lot of nodes come, join or leave the network, which we call churn, then there could be some resources which is unavailable for some time, or there could be some performance issues as some of the nodes hold some specific information in this case. On the other hand, the unstructured P2P network, the nodes come, join the network or leave the network in very random fashion, and most of the nodes are equals, and they just communicate with each other using gossip protocol. They just forward it, but there's no specific routing per se. And these kind of networks are quite robust in case of churn, where a lot of nodes come, join, and leave the network, because all the nodes can serve your request, so it doesn't impose any structure or any dependency on a specific node. So this network can be a bit inefficient in finding a specific resource in the network. But at the same time, it depends on the use cases as well. In this case, you will you will use it for networks where most of the nodes carry the same information. But also, like spreading information is not that challenging, because like there were some lot of like social experiments which were done where someone sent some letter from one location in the world to another location, and on an average, that letter reached by just 4 or 5 people away. Like only 4 or 5 people were needed to reach to drop that letter to the other destination. So in that way, you are able to really get that information or spread that information in a very fast manner, even in unstructured P2P. So I will dig a bit deeper into unstructured. So in unstructured, we have this mesh network. So mesh network is just about like nodes are dynamically creating connections and receiving connections, and there could be full mesh network where every node is connected to every other node in the network, but it can be really inefficient in terms of performance and also like resources when the network scales up to 10,000 or 100,000 nodes. So imagine if you have 100,000 node and full mesh network, you have to create 10,000 or 100,000 connections, and you will also receive connections from them. So it will be it's not that scalable. And on the other hand, you can also have like a partial mesh network where you connect to just subset of nodes in the network. Like in the left-hand side. So you are just connected to some subset of network, and yeah, you can still be part of the network. So spreading information on P2P network is very crucial, and we use gossip protocol. So most of the P2P networks, they leverage gossip protocol, and there can be many number of variants of gossip protocol. And by definition, gossip protocol is is the communication methodology that is inspired from epidemic, like for example, COVID, the way COVID spreads. So in the same way, gossip protocol also disseminate information in the network. Also, like it is inspired from the social gossip. We see one person knows some secret, tells it to other, and then your colleagues will spread it to the other people. So this is how like gossip works. And for example, like the basic example of gossip protocol can be like on the left-hand side, we have this green node, which is holding this specific M1 message. And now it wants to communicate this M1 message to rest of the network. So it will just forward it to its peers. And then these peers will get this message, and they will forward it further, but not forwarding it back to where it came from. So this is how like this information is spread very fast in the whole network, and like it's even like very huge network can get this information within a few milliseconds sometimes. So it's pretty efficient. And you can also like think of it in blockchain in terms of blocks and transactions. So here I will change the context to P2P in blockchain. So you can think of this green node in the left as the forger or creator of the block. It will create the block, and it will spread this or like forward this, broadcast this block to its peers. So M1 in this case is a block. And then the peers, they will forward the block to their peers. So this is how once the block is created, it's spread through the whole network in a very fast manner. And in the same way, the transaction is also spread. So the green node again on the left can receive a transaction from some API, and then it will verify the transaction, validate the transaction, and it will forward it to its peers. And then the peers will spread it around. And maybe on the right-hand side, maybe some peer is one of the next creator of the block. And that creator will receive that transaction, include it in the block, and just create it. So this is how like the transaction and blocks are being transmitted over the network in a very basic sense. So now I will take Lisk P2P as an example in blockchain, where we are using this P2P layer. And some of the features are there is complete documentation about it. There's a LIP, which we call Lisk Improvement Proposals, a scientific paper that is published, and we have implemented all the features from there. So if you want to dig more deep in those features, you can also read that technical paper. But at a broader level, I will just list down some of the features, important features. And one of them is unstructured partial mesh network. So we don't have this full mesh, but partial mesh where you connect with some subset of peers in the network, and we identify incoming and outgoing connections, and this is easier to manage different types of connections. Like you will trust more outgoing connection than the incoming connection. So this is why it gets very easy and also safe for peer selection for request functions, for example. So also the default value right now is you connect with 20 outgoing connections, and you can receive 100 incoming connections. But this is configurable. You can also increase that amount. But this is a sufficient number of connections, even for if you have 10,000 nodes in the network. So yeah, so you can see it's not very resource intensive as well. Then we have different peers list, which you can configure, and you can use it in your application, like a whitelist peer, blacklist, fixed list, and previous peer list. So whitelist is when you want to allow connections in any case when it's coming from that particular peer. Blacklist to always reject the connection from a particular peer. Fixed list is to make constant connection with some peer. And previous peers list will just take all the peers list you had in the beginning and just reuse them instead of going through discovery again and again from the seed peers. So there are different peer list, and you can use them to set up some kind of local network to also safeguard your forging node. And we also have quite a lot of security features, which we do it using peer buckets, dynamic shuffling, eviction, etc. So there are a lot of features around security, but I'm going to just list down some major ones, and we will talk about them in the coming slides. And then there is a banning mechanism. So peers who are acting maliciously are banned for 24 hours. And you can also give partial ban scores, and we'll see this in the coming slides. So talking about unstructured partial mesh network, just magnifying this feature a little bit more. So once you make this connection to any other peer, you are making an outgoing connection to the other peer, and then for that peer you are an incoming connection. So in this way, you have different sense of each connection, and also the one single connection can be used for bidirectional communication. So the peer you are connected to can also send you information through the same connection. So it's a bit more efficient in terms of resources. And then we have peer buckets, which is a special data structure in which we store our peers. And so we have two peers list. One is new peer list and tried peer list. New peer list are the peers which are discovered, but they have never been used to, they were never selected to make a connection to. And the tried peers are the ones who got promoted from new peers who once got successful connection. So this is where at a higher level, we have two peer list, and then each peer list have this bucketing system where the list has n number of buckets. For example, in new peer list, we have 128 buckets, and each bucket can hold 32 peers. And each peer is chosen to be in a bucket using its IP prefix and a random secret. So this ensures that like if no one can spam your peer list, so if someone is sending a lot of bogus IPs, then it will only populate maybe just 3 or 4 buckets in the peer list, but not but other buckets will be unaffected by that. Also, it can stop from the local attacks, like someone starts a lot of nodes from one region and try to connect with you a lot and spam you. But the thing is that even though someone starts 100 nodes, for example, they will only populate 3 or 4 buckets from a region because of the IP prefix. And because of that, you are going to you are less likely to connect with them, because the selection process uniformly selects one of the some of the peers from different buckets. So there's a very less chance that you will select someone malicious, like majority of them are malicious. So if the majority is not malicious, then of course you will not face any kind of attack. We have peer eviction and shuffling, where eviction can be triggered for unresponsive or malicious peers. For example, there are a lot of peers which are added in the peer list somehow, and then they are not deleted, they are just being tried, and you don't connect and you waste your time and resource on that, and it keeps on happening over the network. So we have this mechanism to remove these unresponsive peers, and we also have this dynamic shuffling to keep the connection sufficiently dynamic and less predictable. So this is for this dynamic shuffling is for avoiding structural attacks on peer-to-peer networks. So structural attack could be like it kind of isolate one of the nodes and try to attack one of the nodes in the network, not the whole network, by taking over all your connections or all your surrounding connections. So it isolates you from the rest of the network. So this is some kind of attack on peer-to-peer network, and there was Eclipse attack, I think, on Ethereum in the past. So yeah, so this dynamic shuffling avoids that. It's very hard for the attacker to know your current connections. And we also have internal reputation system for peers. So each peer is tagged with a lot of different internal parameters like latency, longevity, productivity, and also taking into account the net growth. And these reputation parameters are used in case when the peer list is completely full, or like if you have enough incoming connections and now there's a new connection coming in, so you can evict one of the peers which is like less performant based on these params, and you can accept the new connection. There is banning mechanism, and this banning mechanism is for punishing the malicious peers in the network. So if someone sends you an invalid schema, then you just ban them with 100 score, which will ban them immediately. But you also don't want to, like in some cases, don't want to ban completely. You will add some score. So for example, in rate limiting, for example, let's say post node info in this table below. If someone sends this node status or node info for more than 4 times within a 10-second window, then you apply this 10 ban score. So if this will affect the reputation of the peer within the peer list, first of all, but it will not get banned. But if they keep on doing it for 10 times, then they will get banned completely. So all these features we have bundled up into an independent TypeScript library called as P2P. And it's a very generic library, I will say, and you can use it for any P2P use case. It's very simple to get started with as well. Like you just simply npm install, and then you can create a P2P instance. You include the library, and then you just create the instance with simple JavaScript. For example, here I'm passing this node info with the 3 parameters: network identifier to identify the network uniquely, and network version and nuns. So these 3 are, like, by default are being used for handshake. But this library is quite like customizable. So you can customize a lot of things. So you can also customize handshake function in this case, and maybe you just pass some sort of client ID node info. So you can, of course, like, you can always customize these things. Also, you can pass your custom selection algorithm for send, or custom selection algorithm for requesting something, broadcasting. So it's highly customizable, and you can play around with it. So it's as simple as that to get started with it. So you just create this instance, P2P start, and you start running. So your P2P instance is running, up and running. And then if you have like multiple of those nodes, you can already connect with each other, and then you can interact with the network by listening to various events. For example, you have this message event. You can maybe do something inside the event. Maybe you want to check the message type and save it to the DB, or if there's some other DB, and also like you have n number of requests that you can do. I have not listed down all of them here because it's a long list. It's like you can check on the GitHub page as well, like with the full documentation of it. And yeah, I will definitely recommend any P2P enthusiast to try this out, and also check, like, if you want to get more information on this, check our technical paper, which is list improvement proposals, and also you can check the README to use this library to know what you can configure and all sort of things. So now I will talk about List SDK, and List P2P is part of List SDK, and I just want to like briefly introduce you what this SDK can do. So this SDK is like a set of libraries that can be used to develop a blockchain application. So on top we have like this list commander, which is like an entry point for developer. It's a CLI tool where you can just get kickstarted with your blockchain development. Like, you can bootstrap code very easily with just few commands. You can start your own blockchain application, and I will give you an example in the end. And then there is List framework, which is actually creating the blockchain application, also holding the architecture for the application. And List framework is using these list elements, which are independent installable libraries, which are handling specific blockchain logic, or can be a distributed computing logic, or like it can be anything. Like List P2P is one of the examples. Even though it is handling some specific blockchain logic, it can be used in very general context as well. Like, you can create any P2P kind of application. So the architecture which List framework holds to create the application is, on the left-hand side, we have off-chain logic. On the right-hand side, we have on-chain logic. It's like the very broad overview of the architecture to make you understand how you can customize your application. To manage off-chain logic, we have controller, and controller handles all the plugins. And plugins are the pieces which a developer is developing and adding the off-chain logic. And this is communicated through channels. And on the right-hand side, Node is managing all the blockchain-related logic. On the left-hand side, like the screen box, common blockchain logic is already there. And then you can also add your own protocol logic or state change logic in the modules that can be developed by the user. And just again, like, having more clear idea on what on-chain, off-chain logic is. So on-chain logic is something which is protocol related, and you can mutate the state using blocks and transactions. And for example, like we have lifecycle hooks and modules. And lifecycle hooks are like, for example, when a block comes in, you have like the start block or start of a block hook, and then you take the transaction. Then there's a before transaction execute hook. Then there is a transaction execute hook, and then there is a after transaction execute hook, and then the end block hook. So all these hooks can the user can add some logic to it, and so you have like more control over protocol related logic, and you can do it by using modules. And this can be verifiable by anyone, like any protocol logic can be synchronized and verified by anyone. And off-chain logic is something which is not part of blockchain protocol, and it's just something which improves the efficiency of the whole application, and also it fits to your own use case. So these are like added features. They do communicate everything with the main process where the blockchain logic is running. So it communicates and uses all those data, but it's not affecting the blockchain protocol. It's optional to execute, and it's handled as plugins. And I will give you like examples for default like modules and plugins. We have some default modules which we ship through our List SDK, and this is also something which is being used in our existing List network, which is running from last 4 years. So it's quite trustable. And so the default modules are token module, where you use it for token transfers. Sequence module is to handle the nonce property of an account, which takes care of double spending. And keys module is to handle all the multi-signature registration, transaction verification, all sort of things. And DPoS module, which stands for delegated proof of stake module, is responsible for delegate registration, voting, unlocking when you have voted something, and then there's proof of misbehavior transaction if some delegate misbehaves in the network. Also, there are default plugins which we ship through List SDK by default. These are HTTP API plugin, so that exposes REST endpoints to access blockchain information. Forger plugin is to monitor delegate activities for monitoring purpose. Report misbehavior plugin detects some misbehavior done by a forger automatically and creates and broadcasts this proof of misbehavior transaction. And monitor plugin in the end exposes all the node related information, how many peers you are connected to, what are the constants which are being used, and all those things, and also exposes it to Prometheus format for monitoring purpose. I think maybe these are too much in detail. Maybe report misbehavior plugin is something you can also check it out on our documentation page. So yeah, so these are some examples for modules and plugins. And now, like, I will briefly go through all, some of the features which are quite developer focused that we added in the newest version 5.1. So you can bootstrap your blockchain application using List Commander. List Commander is the CLI tool, as I mentioned before. Once you install List Commander, you can write List, and it will list out all the commands that are available. And there are a vast set of commands available. There are subcommands, for example, list account : get. So there are subcommands within the commands. And the most recent ones which we added were these bootstrapping commands. So you can write List in it. It will create your blockchain application like a full skeleton, which is runnable. And then you can start adding logic to it using list generate command, like creating off-chain logic, on-chain logic. So I will give you an example in the end. Also, we have added dashboard plugin, which is a web UI, one-page web UI, where you can see all the activities happening in your network. So you can see how, recent blocks, unconfirmed transaction, recent transactions, accounts. So it's similar to like what Explorer is, but like a minimalistic version of Explorer. And the good thing about this is this plugin is that you can also interact with this UI. So all the types of transactions will be listed here. You just select from the drop down, give the passphrase, add your JSON object, and that's it. And also all the actions that you can call, which are like RPCs, and you can call all these actions which are also available on the drop down. So it's a very nice utility for a developer who is developing their application, so that they don't have to like go check the logs and all those things. They can just simply check it here in this UI very simply. Also, once the user has developed its blockchain application, it wants to like test this application with the real users. So to test with the real user, you want to send some tokens to them as well. So this is like a one-page web UI which you can use to send tokens to these users. And it's also configurable. You can change logo and the application name using the configuration file. So just to give you an idea how easy it is to get started with creating your blockchain application is just first install Lisk Commander, then you write Lisk init. You can also give path as well, but you can also simply write Lisk init in the current directory, and it will create the application for you. So it will ask you some questions very similar to npm init, like asking you the application name, application description, and then it will create your Genesis block and configuration and everything, and it will create your application. And now you can use your own CLI. So for example, here I gave application name as my app. You want to use this CLI instead of using Lisk. Like you can just use it for your own development purpose. So you can install it in the current directory. You just write npm I g, and it will install this CLI globally. So it will be available on your terminal. So then you can just simply write my app start. So there are a lot of commands which will be there in my app. You can also like think of some other name like gold token or something. And let's say you just write gold token start, and it will start your blockchain application. So now your application is up and running, but it is just having all the defaults and all the information, or like all the modules which are coming by default, all the logic, but nothing your logic. So now you can start adding your own logic in the current application. You write list generate :module, give a module name and a module ID. Module ID has to be greater than and equal to 1000, and it will create the module skeleton along with the test files, and also it will register your module. So now this module will have all these lifecycle hooks, and all you need to do is go in the module file and start writing your logic. So it takes away all the pain, to scaffold all the files and structure and so on. And same goes for plugin as well. You just generate plugin by using list generate plugin and give a plugin name. It will create the skeleton, and also it will register the plugin along with the test files. And again, I want to come back to this P2P library. You can also create like your own light client or client node in the network. Just to give you an example, once you create your own blockchain application, it's up and running. Maybe you want to have some client nodes which don't really process any blockchain information, or like create blocks or verify blocks or something, but they can be used for some other purpose, maybe like a relayer or something. So you can have some set of client nodes across your network which can have some utility in the network. and it's very easy to create as well. For example, in this code, you just create the instance, give the network identifier as per your blockchain application, and give the right network version, and you will get connected with your network. And then you can start monitoring different events, different like you can call different functions, like requesting some information from a specific peer, or also request in general, which will randomly select a peer from your peer list. And also, like, you can get all your connected peers, your disconnected peers. There are a lot of events actually. You can it's not only message, but you can also control very small, like very granular level events as well, like when a new peer connects a network, joined your or connected with your node, or if a peer got disconnected, or if peer got banned. All these events you can like have. So you can create some sort of monitoring tool out of this client node as well, to like have some overview about the network. So yeah, this is like one of the utilities I was just wanted to highlight. Yeah, and if you want to know more about Lisk, and like you want to know exactly how to like develop a blockchain application for yourself using simple TypeScript and JavaScript, you can tomorrow join this workshop led by Manu, who is the lead backend developer at Lisk, and he will give you some overview about the Lisk SDK, some information, and also he will walk you through with the development of one of the use cases, and you will get enough time to follow him. And in the end, we are aiming that everyone creates one blockchain application. And just to like a short note for that workshop, if you are thinking to join that, please, like if you want to get started well with the workshop, maybe you can already install Node.js, this particular version, and check your version if it's correct, and install Lisk commander, check if the Lisk command is available on your terminal. So it's a very small thing, and yeah, you will be like, for sure, like I think you will enjoy that workshop, and you will find it like how easy it could be to develop a blockchain application by yourself. Yeah, so thank you very much. I hope you enjoyed listening to me. I hope you you found something informational, something nice, and let me know if you have any questions.
And I definitely enjoyed that, Ishan. So a big thank you to you. Unfortunately, we're pretty much out of time. But I would like to say that people should definitely join the workshop for tomorrow. And I like that you kind of gave them some quick tips on how to not spend the first 10 minutes frustrated, like frantically trying to install stuff,
Yeah.
and trying to catch up. So that's a great tip. Now, if anybody would like to see more from Lisk, of course, they could join the workshop tomorrow. But as I said, you're also part of the expo, and if people are looking for jobs at Lisk, they can go there and check out some of the jobs, and they can. There's some more documentation on the SDK, I believe, there in the booth as well, and they can talk to some of your colleagues who are delightful as well.
Yeah, I didn't realize the time went too much.
Don't worry about it. Don't worry.
Yeah.
Oh, actually, a good one. So for the questions that got asked that we don't have time for right now, can people reach out to you via Swapcard?
Yeah, sure. They can reach out to me through Swapcard. Also, they can post their queries on Lisk chat. So they just write lisk.chat, and they will be redirected to Discord channel. So there they can ask any questions if they want to. Yeah.
Excellent. Well, I want to give you a big thank you again for your presentation and sharing with us. And
thanks, Justin. Yeah.
My pleasure, our pleasure, and big thank you to the audience for watching. Enjoy the rest of the conference. Bye-bye.
Yeah, thanks. Bye-bye.
Bye.
Have you found your dream job as a developer? Or are you stuck in an unfulfilling job? On WeAreDevelopers.com, you find over 1,000 jobs in Europe that fit the tech stack that you want to work with, and salaries go up to $130K. All you have to do is create a free profile, and you automatically get matched with jobs that fit your requirements. So what are you waiting for? Create your free profile and let companies apply to you now.